Hey guys, so today we're going to be moving on from our unit rate section. We're going to move on to proportional relationship. I want you guys to continue to work though and think about unit rates is when the denominator is 1 and we have some quantity over 1. So based on that idea, I do want you guys to pause the screen right now and go ahead and write these notes down in your notebook in Cornell note style. I have it laid out for you. We're going to be our essential question is how can you identify and represent proportional relationships? And the key there for today is going to be just finding the unit rate. So go ahead and pause it and copy down these notes, and when you're ready, hit play and I'll go into some examples. I'm just going to quickly read it for you. Proportional relationships. We're going to be using the rate of change, a rate that describes how one quantity changes in relation to another quantity. Proportional relationship is between two quantities. The rate of change is constant, which means it's changing the same each time. A rate of change, a common rate of change, could be basically a unit rate if you think about it for a second. So if I have, for example, 50, if I have 50 miles for every 1 hour, that's my rate of change. For every 1 hour, I can go 50 miles an hour. And then if I go to proportional relationship, here's a proportion. A proportion is when you have a statement that two rates are equivalent, which means on both sides of the equal sign, both of the rates are equal to each other. So if I have 6 miles for every 2 hours, I get 3 miles over 1 hour. That is proportional. Okay, or 2/4 is equal to 1/2. They are proportional. They basically come from each other. Okay, moving on. All right, I do want you guys to write this example in your notes because we will see a lot of these tables. Example number 1, if you want to pause it, copy it on the table, and then jump and then push play when you're ready. Go ahead. I'll wait a second. Okay. No, example 1, determine proportional relationship from this table. First, it's going to ask you, is this table a proportional relationship, or just proportional? But don't worry about the relationship. Okay, so the fastest way to figure that out is look at your heading. We're going to pop this question real quick. This is money over hours, or hours money. I know that because we have money in hours, it's going to be money over hours. And basically this is very similar to what we do usually on Tuesdays, trying to find a pattern or a sequence. So we're going to find the unit rate that will allow me to quickly determine if it is actually proportional. There's a couple ways to do that. If you're looking at a table from left to right, you're going to go, oh, okay, it needs to start at 0, 0. Okay, it's got to start at 0, 0. That is x, y on a graph. It's got to start at 0, 0. That's check 1. Check 2. Is there a constant pattern? Is it moving constantly? So, for example, I would go 1 hour to 2 hour. So that is plus 1. And then $9 to $18, that is going to be plus 9. Okay, 2 to 3 plus 1. 18 to 27 plus 9. 3 to 4 plus 1. 27 to 36 plus 9. So we can say that my unit rate is $9 for every hour. And this is a proportional table because if I multiply each hour by 9, it works. 1 hour times $9 is $9. 2 times $9 is $18. 3 times $9 is $27. So yes, this is proportional because my constant is $9 for every 1 hour. Okay, so those are some ways for you to determine if a table is proportional. Finding the same number that you can multiply to the left column, and it works every time. Because if it doesn't, if one of them doesn't, then it's not proportional. Or you can go back to the unit rate. Luckily, the unit rate for this one's given because I know that I have the hour right there. 1 hour. Okay, moving on. Example 2. How to determine proportional relationship for example 2. Callie earns money by dog sitting. I actually want you guys to write this down in your notes. So pause the video, copy this example down, push play when you're ready. Based on the table, is this relationship between the amount Callie earns and the number of days a proportional relationship? Very similar to example number 1. Number of days, I have 1 day, she earns $16. Well, so right away, that's my unit rate because I have money over days. Okay, because money is important, I'm going to put it on top. If you did days over money, that would work too, as long as they're moving, constantly moving together. Okay, that is actually called a constant of proportionality. Either way would work, but most of the time, since we're dealing with money and time, money goes on top. So here we go. So she works 1 day, the 2 days, that's plus 1. She gets 16 to 32, that's plus 16. So far, it holds true. She gets $16 per day. We're going to continue this pattern and see if it works. Okay, it's 32 to 48, that's also plus 16. 2 to 3, that's plus 1, so 1 day. So we can say that this is proportional because, yes, because she makes $16 for every 1 day. Okay, and we can actually quickly test this out because if she makes $16 for every 1 day, we can take this number and we can multiply it by $16, and if it equals 64, which it does, because 60 times 4 is 64, that also checks out because it works. And then you can do the same. You can take 5 days and you can multiply by $16 and you get 80. So this is proportional because it is moving constantly with the same unit rate. Also, it starts at 0, 0. Because if she worked 0 days, she made 0 money. Okay? Moving on. Example number 3. Pause the video right here, copy this example down. We will see some more of these, so you will need this in your notes. Okay, here we go. 2 pounds of cashews shown cost $19 and 8 pounds cost $76. Show that the relationship between the number of pounds of cashew and the cost is proportional relationship. Then write an equation for this relationship. So this is a new bit right here. We're going to write an equation. So the first thing let's just jot down what we know. I know that 2 pounds is equal to $19. Okay, so 2 pounds is equal to $19. I also know that 8 pounds is equal to $76. There's a couple ways we can do this. I am a firm believer in when in doubt, write it out. So I'm actually going to make a table. Okay, so I'm going to make a table very similar to the last couple examples that we've seen. I'm going to make a t-table. Okay, where I have money on the right side. That's my output. My input is the pounds. I'm assuming that if we have 0 pound, it costs 0 money. So far, so good. We also have 1 pound, 2 pound, 3 pound, 4, 5, 6, 7, 8. I don't know what 1 pound is yet, but we think that, well, we know that 2 pounds is $19. I also know that 8 pounds is $76. We have 2 points in time, so we can actually work backwards and we can find the unit rate. So I'm just going to pick one of these numbers, this set, so we call those ordered pairs, and I'm going to go over here. I'm going to go $19 divided by 2 pounds. Okay, and we're going to figure out that that's going to give me, if I divide that by 2, okay, I'm trying to label my units here so I don't lose anything. I got 2 pounds. So when I divide that by 2, I'm going to go back to its unit rate. I should have 1 pound. Okay, and 19 divided by 2 is going to be $9.50. Right, because 18 divided by 2 is 9, so 19 divided by 2 is 9.5. So 19.5 pounds. So I'm going to go ahead and write that in. 9.5 pounds. Or excuse me, $9.50. So if this is true, here's one way to check it. I know that plus 9.5, that should give me 19. I'm just going to continue it. I'm going to go, oh, okay. I'm going to go 19 plus 9.5 is going to be 28.5. And then 28.5 plus 19 or 9.5 is going to be 38 for 4 pounds. And we're going to add 9.5 to that. We're going to get 47.5. And we're going to add 9 to that. And we're going to get 57.5. And we're going to add 9 to that. 9.5 to that. And we're going to get 66.5. And we're going to add 9 to that. And we're going to get 76. So it works. Every time I go up, I add 9.5, 9.5, 9.5. Every time I go up 1 pound, it goes up $9.50 or $9.50. So this is a proportional relationship. Now, there's another way to do this. If you want to think about it, you don't have to go all the way down like I did right here. Once you find that unit rate, you can actually multiply each of these by $9.50. $9.50, and it should equal out. That's another way to do it, because once you find the unit rate, you can multiply that constant with anything on your input value or your number of pounds there, and you should get out. So let's go back to the question. Is this proportional? Yes, it is, because it costs $9.50 per pound. Okay, and the next part says, hey, I want you to write an equation to figure out any amount of pounds will give me how much money I need to pay, or I need to write an equation for this relationship. Well, to get the cost is equal to, well, what's my change every single time? What am I multiplying? What's my rule? Really though, write an equation for this relationship, that's the exact same thing we do every single Tuesday when we do sequences on Tuesday. We're writing a rule. The rule is, I don't really want to add $9.50 each time. That's too long. The shortcut is I'm going to multiply $9.50 with every pound for P. Okay, so in this case, I'll define my variable. C is equal to cost. P is equal to pounds. And there's my equation. Okay. All right, that's all I have for today. Thanks, guys. Make sure you guys pause the video and take notes, and then rewind it if you need more explanation. Thanks.